Hello everybody, welcome to my talk about the unstoppable session layer. My name is Alexander Aring. And yeah, what is the unstoppable session layer? The unstoppable session layer solves a problem for me in a connection-oriented socket lifetime, where we have the first priority is the reliability. Then we have a socket, for example, TCP or SCDP. In my case, it's the distributed log manager in the kernel. Then in this distributed log manager, we joining a cluster resource, and over the lifetime of this join and leave of the resource, we need to have 100% reliability. The problem here is the socket lifetime. When we getting for some unknown reason a reconnect, and then we the reconnect mostly works to reconnect, and then but when we having a reconnect, we have a new socket, and this may end into data losses. So for example, here we start our socket from one PC to another endpoint, and we're sending some messages out. Then we, for some reason, maybe some middle boxes send us TCP reset, and we're getting a connection error. We reconnect, which works most of the time. Then we're getting a new socket where we have new messages on, but the message which was maybe in middle boxes or in socket queues are getting into the garbage. So how we solve this problem is we transmit on reconnect. We have an encapsulated header. We have a simple sequence and acknowledge-based mechanism on top of the transport layer. Then X getting also piggybacked on message back. We using data payload to just put the X on it. Then we retransmit all non-ACK message after we reconnect. How does it look like? We have our socket again. We have our second error. We reconnect, which we assume it is successful. And then we retransmit all the message which are not acknowledged yet. Why are we doing the retransmit on reconnect? So we want to have this issue that we lost some message very fast resolved. So we can imagine on our distributed log manager, we have a hot pass. We making logging requests, we getting log grants back and everything else. So we don't want to resynchronize our log database with all other nodes in the log manager, and we want to resolve the issue about a reconnect, and maybe there was some message lost very quickly. So we just want to have a jitter in our communication latency, but this is very quick resolve, and the application to do synchronization, that every node which participate in this log manager protocol stops all the logging, and then they making a grace period where they're looking on the log database. It takes too much time, and when it's only a reconnect, we can do that. But in the distributed log manager, we have also that we can resynchronize the whole database, but this is only necessary when we're using the application state fully, like in a power outage. So, but this talk is more focusing on how you can transparently USLify your application. So the transparent in a way that you don't need to program, you need to change your program in any kind of programming. So what the idea here is like what TorSox is doing. TorSox is a project from the Tor project, and you can put it in front of your networking application, and then everything outgoing traffic redirects to a SOX 5 Tor daemon, and then you Torify your application that it makes everything through Tor. The main mechanism what they're using there is LD preload environment variable, and but TorSox is not really easy like this. It does also do some DNS resolving, and that it is also done over Tor with get host by name and something like that. It's a more complicated project. So LD preload, what is this? This feature can be used to selectively override functions in other shared objects. This is a quote from the man page. So the idea is here, at first you can maybe override your networking related syscalls. So you can put LD preload in front of the your networking application like TorSox is doing. You can hide it in a script. TorSox is also only a script which is sending the LD preload environment variable. Then you can also pass parameters if you want. So the problem with just override everything is you can imagine that, oh yeah, I can encapsulate my send and then decapsulation in my regv syscall. Don't do that because there's a lot of different methods how you can make I/O on a socket. You already know that, like regv message, send to, and everything else. I try to do that, but it is a lot of things to maintain. Mostly impossible when you also think about new methods, IOUing on a socket. This is very difficult to maintain. So we need to hide also the socket errors. So when we getting a socket error on a send, then the file descriptor getting unusable, and we need to reconnect, and we need to hide all this mechanism from the application. So the solution here is override only connect and using a socket proxy. How does it look like? You have your application like Netcat, it has a socket and your final destination. Then you have a socket proxy in the middle, and we assume that the connection between the socket and the proxy never fails, and between the proxy and the destination it can fail and reconnects then. So this is a flow diagram here where you can get maybe more idea how it works. We have a client with a USL in front. It calls Netcat, then it connects not to the final destination, it calls to a local proxy, which sends the real destination address to it, and then it also connects to a proxy on the server side, sending also the real destination to the proxy, and then the proxy on the server side connects to the real server. Then if you want to send something, you send it to the proxies, and in the middle of the proxy connection, you have the encapsulated header, and they are encapsulated again with the raw data for the client. So the other way around. And the important part here is, like I mentioned before, between the proxies, the connection can fail, and then you reconnect and transmit if it happens. And all these socket errors are being hidden by the applications. So what I want to mention is that LD preload is difficult to maintain, as I mentioned, with the regv message and all this send message call. When we introduce a new have a new method to make connect, then you need to update your application. Maybe there can be a nice new project out of it that we have a more stable way to do that, because currently it is the user space need to update all the such project need to update always new methods to calling connect if there's a new way, or we introduce new flags to different calls. Yeah, and maybe there can be a new project how to make it more stable, because I see that we have in the kernel only one way to do things, like in the socket operations that we have send message and regv message, but in the user space you have end message to do that. But I don't look more into this in this talk, because LD preload is a nice toy. We look into other options, but maybe you got some new ideas which you can use in your project with LD preload as a solution for now. So another thing what I want to look into is socket multiplexers. In my definition of a socket multiplexer, you have in the user space some address family which you open, foo, for example, and then you have several sockets, and then in the kernel there's some logic which maps the regv send message and other calls to the socket to other socket about in the kernels. it creates the other, like AF TCP in the kernel, and then it maps to it. And there's always a logic in the middle who makes some modifications. So another, in my opinion, multiplexer in the kernel which already exists is RDS. RDS can live in the user space, or there can be multiple RDS sockets in the user space in different processes, and it's also 100% reliability like USL. It also uses encapsulated header. It has its own port handling because all these RDS sockets in the user space can multiplexing it into one socket like TCP, but it requires adaptations, implementation like for TCP, or there's also RDMA inside, and they have also kind of multipath implemented, like creating more multiple TCP sockets and doing load balancing there. But this is not MP TCP to avoid head of line blogging. So how does it look like in a nice graphic? You have on top multiple sockets in the user space of RDS sockets. Then you have your multiplexer logic, and it puts everything into one 100% reliable TCP socket. And then it has on the other side demultiplexing thing because it needs to de-encapsulate it like USL. So another multiplexer is the kind of connection multiplexer. It is AFKCM. It's an N2M multiplexer. You have N AFKCM in the user space, and then you have some multiplexer logic in the kernel, which does some load balancing. It also has some PSOC module, which does frame message framing, for example, a byte stream like a TCP. And the load balancing logic is mostly like when an application is blocking for waiting that there's something to receive on the socket, it will deliver to the RFKCM socket. If it's not blocking and waiting for socket to receive, it thinks that the application does something else. On the other side, when the TCP socket is congested, then it uses the next TCP socket and the next one, and so on. And there's the counterpart in AFKCM. It doesn't exist because AFKCM is not like RDS, which does encapsulating. It's more designed for servers, and yeah, it's a different kind of multiplexer. So USL could solve a node in the AFKCM KDoc. I coded here that there's a special part mentioned that the socket TCP socket is not recoverable when there's a error is occurring, but USL could solve this. And I was thinking about how we can extend AFKCM with USL, and I come up with this moonshot idea, like which I named socket control. This is an approach how to make AFKCM programmable. It's not programmable yet, and I want to show you now what I mean with programmable. And this point, it's like in the electronics, what is a multiplexer? You have, for example, here two one multiplexer. You have two inputs and one output. Then you have some abstract switching logic over a signal line, which is user controlled. You can say which input goes to which output at one time. And what is a multiplexer in the electronics from inside? It's just some AND and NAND gates, and the signal line is connected with it. Then in our multiplexer IC, that's an integrated logic. What I want to show you now, the logic is static, so you can actually buy such IC like this, and you cannot change the internals of this multiplexer, and the user cannot change the switching logic of some IC like this. And such IC is only specific for the use case. So I claim now that the existing socket multiplexers like AFRDS and AFKCM are like ICs. The logic is static. You cannot change them. It's only made for a special use case. And yeah, you can put AFKCM on some integrated circuit like this. So, but now going back to the electronic point of view, how you can put the logic of our integrated circuit in a multiplexer, you're using the primitives and wire them together, like primitives and wiring with some electronic wire together, and then you can build your own multiplexer, which is your use case, what you need. So I want now to adapt this idea to AFKCM. Here's a small example with one-to-one multiplexing. You're having your multiplexer logic modules, and you can then wire them together. As an example, you're having the existing PSOC module. There's also a little bit ePPF script inside to make some L7 application-specific handling. Like in this case, it's need to evaluate message lengths. And then over some UAPI, you can wire your own multiplexer logic together. In this example, AFKCM can already do that when you're using AFKCM in a one-to-one logic. But if you add more sockets to AFKCM, the multiplexer logic does something else. And maybe you don't want this, and then you can wire it like you want to have. So you have your logic module is like, for example, PSOCs. Another example, AFKCM is already very good in defining multiplexer sockets, so the input and the output. It has IO-CTLs where you can defining, I would say, input, which is the top sockets, and the bottom sockets. You can also map them to TCP sockets with attach and unattach. And yeah, the idea of reusing AFKCM implementation is that we let them, we can make it more modular, like what currently AFKCM is doing, but the user can flush all the program and the default logic of AFKCM and then wire everything together once it's needed. And when we having it as a default logic, it behaves as it before, but it's just that over some UAPI, the multiplexer logic can be reprogrammed. So how this fits with USL, you're having your AFKCM, and then you can wire things together to have, for example, a USL module, and then this is over a UAPI, you can wire these things together, and then it's getting reliable. And you have your message framing, which we already need for USL because we put message on the TCP sockets. And this is just an idea. Another more complex idea would be, here I have on the left side only the transmit view, and on the right side the receive view. You're having redundant multipaths, like SKB MIO on the transmit side, that it mirrors onto TCP sockets the same message, and then over some, on the receive side, over some first come, first served, it will deliver the first message to the AFKCM logic. This could be useful because if reconnect doesn't work anymore, then we have still another path which works. So compared to transport layers solutions, I was not looking much into it, but I know that something like USL exists for Quick. They having a draft about reliable stream resets, which is something what probably USL could solve. It is a similar idea like USL, but it's only on the transport layer. But I need for DLM, for the distributed log manager, I need to have some kernel socket support, which is currently, I think, still in progress. And with multipath TCP, it can survive also with CO subflows. But how you can trust MP TCP that it never ends in a socket error that you need to reconnect. I'm not sure about this. And also because head of line blocking and load balancing, what the existing multiplexers is about. It's quick. You can using streams on. You can using quick streams, and you can make your load balancing on I guess your application layer. And multipath TCP, they have these path scheduler. I don't know if you can control your load balancing then on the application layer, or it's only using it on segments. But that would be that could be also being solved by the transport layers. But future work, maybe the transport layer, what I wanted to say is that there may be overkill. I'm not doing any internet related connection over internet. I'm only in a private network and having my clusters connections going on. And I think Quick can probably solve all my problems. But I need to look into Quick more and getting at least a kernel socket, which is not possible yet. And USL already existing for the TCP and SCDP support in DLM. But I don't have the multipath idea yet there with the redundant TCP socket. Maybe I want to try to move out this USL out of my application layer, and I try to find where I can put it into it, and AFKCM to make it programmable could be one solution. And then I can maybe update the SSDLM to use the AFKCM. And doing the programming of the multiplexer. So I hope you joined this talk. May the LUTP trick was new for you. You may like the idea of the socket control, which I approached here. And sorry that I didn't talk about the half closed loop socket issue. Maybe next time. And I didn't show the netcut demo with the boxes solution I showed. But another solution would be to using socket multiplexers. Thank you. So, does anybody has any questions?
Sure, I have a quick question. For the AFKCM, are you planning to upstream that?
You mean that you can program your multiplexer? I did not start the coding yet, but sure, when I have code, then I plan to upstream it. And as I said, I want to get it out of my application layer, what I did there, and that would be an example to doing it. Yeah.
Okay, thanks. Because the stream parser supports KCM. So yeah, sounds doable and sounds very useful to make KCM applicable to more use cases like this.
I need to say that we have all these. I didn't want to introduce a new address family and then to reprogram it and then using the existing AFKCM. That sounds like a nice idea. And if somebody has a new idea and put it somehow into it, then we can easily put it upstream. That other people can use it. I'm sorry, I did not hear the room last time. If there's still another question.
Yeah, another question? Yeah. Alex, so if for the connection thing, like tracing, so if this is message-based protocol for like a quick do you think all those problems will go away, or?
No, what Quick is approaching there, as I was reading the IETF draft, is that they want to make streams reliable even if there is a stream reset going on, and also with an error and you can also say how many bytes it should be reliable, but the difference in USL is only on top. It's only on top of the transport layer, and then we transmit what you forgot, what you talk. But I think with the IETF draft so far, I was reading it. You can get 100% reliability over a reconnect. But I'm also questioning me here how you want to put Quick on a BSD socket.
Like, if these kind, itself is like, stateless, then the session is not needed, right? So in that case, reduce the state. So then, will not affect that much by the, restart the connection thing, right? So if we can possibly.
Yeah.
Okay, yeah.
Okay. So if it's stateless, then it's better because we don't lose any state.
Any more questions? Nope. Okay. So thank you.
Yeah. Thank you.